Good morning. My name is Dennis Falloon, and I'm the District 7 Agency Traffic Safety Academy Coordinator. And I'd like to welcome you to the third webinar, uh, about the Highway Safety Manual. And it's the third in a series of 12 that will run, it began on October 23rd and will run through January 29th. And after that date in January, we'll begin them again in February. So just look forward to that. There'll be emails going out about it. Go ahead, Anthony.
Oh, slide. Good.
Yes, slide. Sorry. What is this academy? It's an academy to provide information regarding safety-related issues to enhance your local safety programs. Slide. Go ahead, Ian. Okay. It began on October 23rd. It's the first cycle, like I just said, that ends on Wednesday, January 29th. The topics run from an hour to no more than 2 hours, and the length of each webinar will depend on the topic being presented. This is where you can go register the SurveyMonkey. That comes out on your emails. You got one for this meeting and has that link in there. And then also you can go to www.d7safetysummit.org to register for the webinars. Go ahead, slide. This is a list of the webinars and topics. Today we're on November 6th, and it shows you what runs through January 29th. Go ahead, slide. If you need any assistance, it's at the bottom of some of the forms that have gone out in emails, but here's my contact information, and please feel free to contact me. Some of you have previously, and I'll be more than happy to help you. And once again, welcome. And I want to let you know that Joe Santos, the state safety engineer from the FDOT headquarters in Tallahassee, is going to present the Highway Safety Manual. All right, Joe, it's all yours. Thank you.
All right. Thank you, Dennis. Yeah. And thank you, Anthony, for that polling, because I think it was very important to be able to get everybody's input who's participating today. I need to see, there we go, show my desktop. Got it. Okay. All right. Bear with me for a moment. Okay, excellent, we're good. All right, so this is our third session, and I've been asked to speak to the Highway Safety Manual. As Anthony, or both Dennis and Anthony mentioned, presentation today is a little over an hour, and considering that we have folks on board that are hearing about the safety manual for the first time, I'm going to be diving into some really basic material concepts and such in regards to the Highway Safety Manual. And then for those that have heard about the manual and have attended the trainings, then I will provide a little bit of updates near the end as far as new resources that have been posted out there. So I think when this is over, I think this session will be of value for both those hearing about it for the first time and for those that have attended training and such. This is just the same slide that Dennis had showed earlier. It's just a matter of seeing timeline-wise the other trainings that are planned. Okay, before we start out, I just want to say with HSM that it's a whole different, with the use of the Highway Safety Manual, it's a whole different perspective on addressing transportation safety. Ezra Hauer, who was very instrumental in the research of the HSM, basically provided the following quote, that road safety management is in a transition. The transition is from action based on experience, intuition, judgment, and tradition to action based on empirical evidence, science, and technology. Basically what that boils down to is rather than just reacting to where the crashes are occurring, with the HSM, we have a more proactive tool in our toolbox where we can scientifically determine, based on our best data, where we might have the most prone to a safety concern. So kind of sets the stage there. And the other thing on this particular topic, when it comes down to the local projects, just kind of let the information kind of sink in a little bit, kind of get a general perspective of what HSM is about, because you may find that we may have projects that are being submitted from local agencies that may not be a good fit for the Highway Safety Manual, but we may have other projects that would be good fit. So the intention of this presentation is just to provide a general overview, and then we would team up. We would ask that the locals team up with district champions to to see if the use of the HSM is a good fit. So some of the learning outcomes today are talking about basically the overall purpose of the Highway Safety Manual. Here we see the front cover. This first edition is dated 2010, and that is the latest. We're going to cover a bit about who our audience is, basically the general structure of the Highway Safety Manual, what the general advantages are, and then end up with some resources. A little bit of background. As I mentioned with Ezra Hauer's quote, that we're looking at a science base, and what we're doing with HSM is think of it as another tool in your toolbox to measure traffic safety in all aspects of highway and traffic engineering, and we're extending this back to include both design and operations. So how important is safety? Talk about safety. It's kind of number one on our list, on our mission statement within the Florida Department of Transportation. On the first session, we talked about our Strategic Highway Safety Plan, very large component in what we do as an agency. So it ties in well with programming prioritization. When we get into systems planning and such, we want to be sure that we are developing a safe system. Program administration, policy development, all of these different areas, safety is a huge component in what we do as a transportation agency and as transportation as a whole within the state. But many times addressing safety is a challenge because we're balancing it with other needs. Mobility needs, a lot of on the mobility in regards to such as access management, connectivity, safety, costs to incorporate these projects that address safety, environmental concerns. There's a lot of trade-offs that we have to balance in order to really address safety. So one of the key components in understanding what the proper use of the Highway Safety Manual is that, asking that question, what is safety? If you were to go into a room with 10 people and you asked this question, you would probably get 10 different answers. So it's important as we talk about the Highway Safety Manual that we are very clear that we're using crashes as our measure of safety. We're not the challenge, though, many times in transportation is that we're not including the feeling of an unsafe road. Many times we may be addressing with the public about their sense that this road is unsafe, perhaps based on the posted speed limit or the types of vehicles using the facility. If there's a high number of larger vehicles, a large number of pedestrians, this whole balance, it may be somewhat subjective in feeling unsafe. But what we are trying to do with the safety manual is to use more of a scientific approach to determining the safety component of the facility. So what does the HSM do? Basically, what it helps us to do is to quantify safety in terms of crashes, and it provides us that tool to do that. This quantitative nature of the HSM really allows for the meaningful performance measure of safety. You know, this what we're going to talk about in predicting crashes. That makes it more of a performance-driven component in your decision-making process. So, what we try to do in this particular overview is try to find an example of what we can compare it to. And the Highway Capacity Manual is one document that we can look at as kind of a comparison with the Highway Safety Manual. Some of the similarities is that it's very definitive in its approach, and it represents a quantitative, scientific-based method to develop the information, in this regard, crashes. The other part is that with the Highway Safety Manual, it's widely accepted. Widely accepted in this regard is basically saying that our American of Highway Safety, Highway Transportation Officials, or our AASHTO group, has endorsed the Highway Safety Manual and provides it as a publication. So it's very much widely accepted within the community and the professional practice. And the last bullet, third bullet, is that it is very much science-based, research-based included. Highway Safety Manual has more than 10 years worth of research to back up its principles and such, and also being regularly updated. We have recently gone through some recent improvements to the HSM to include both freeway and interchange segments. So it is being updated on a fairly regular basis. So why do we need it? When we talk about safety in regards to crashes, and we're trying to address, public's concerns of roads that feel unsafe, we have to realize that we have limited resources, and so in order to really capitalize on whatever resources that we do have, the Highway Safety Manual helps us to delegate those limited resources where they have the most need. And the science and technology component is that we have the data, or we can acquire the data and the scientific principles to develop this practice. And in regards to legislative mandated priorities, when we speak to safety overall and bring our numbers down, we have core Federal Highway Administration safety programs that really help us to kind of focus these priorities in addressing safety in regards to like what we had talked about in session 1 with our strategic highway safety plan. The other big question on the HSM, where can the HSM be used? It can be used basically from a statewide level down to a local level. So pretty much everyone on this training session can apply it. I mentioned briefly about facility types. Right now, we've got limited facility types: 2-lane rural highways, rural multi-lane, urban suburban arterials, and these would be to include both the segments and intersections. Freeways are brand new, but today I'm going to focus primarily on these facility types that are presently in the Highway Safety Manual. And Then a big question, who's the target user? I'm going to share with you at the very end a resource that FHWA has developed to basically show examples of how the HSM can be used in regards to, developing a long-range transportation plan, or, a good application for our transportation planners. Other examples for traffic engineers, or more of a project-specific component for our traffic engineers, safety engineers, and designers. And capital programmers, when we start talking about looking at a systemic approach or network screening kind of component, that would tie in well with in that area. I kind of mentioned already about the systems management. Basically, the HSM, Highway Safety Manual, has a component where we can do more of a kind of network screening, determine based on your facility type and your existing condition, and doing a predicted crash methodology on those facilities, and along with more of a project development, which is a bit more detailed in regards to base conditions for the various facility types. So the HSM can be used to identify sites with potential for crash reduction. That ties in well with our network screening component. Also identifying crash patterns and treatments. Crash patterns would be such that lane departure type crashes, intersection type related crashes and such. We can look and do, based on our predicted methodology, we can do some economic appraisals based on that information, and then we can evaluate, once we have the countermeasures in place, we can actually evaluate the crash reduction benefits from those countermeasures, and we can use that to further quantify or basically get a better estimate of the crash reduction effects for our design decisions. So that's the general overview so far. Anthony, I was just curious, have there been any questions posted just yet?
There are no questions in the chat so far.
Okay,
if anybody
very good.
has,
thank
you. Feel free to post them there.
Okay, because I'll take like a little break, every so much, just to kind of allow opportunities for questions. So one of the other key components when it comes to the Highway Safety Manual is that we are looking at more of a substantive safety. Substantive safety in this regard is basically looking at the actual or expected performance of a roadway facility in terms of crash frequency and severity. That's something that has not been a tool in our toolbox to address substantive safety in our decision-making process. Prior to the Highway Safety Manual, we were addressing nominal safety based as adherence to design standards and practices. If we met the design standards, we were nominally, addressing safety through different standards, such as our geometric design of highways and streets, our green book, different design that we have as an agency. So that's one of the big changes here when we are addressing the nominal safety as compared to substantive safety. So when we look at substantive safety, granted for this HSM, we're just looking at the crashes and such, but we look at, when we start talking about substantive safety, we want to take into account just not only the basic characteristics of the road, but also the function of other key components such as maintenance, our law enforcement, and any other resources that we have to make that facility operate as it's intended. So substantive safety, it's a new term that HSM is applying. So if we're looking at comparing the nominal safety versus substantive safety, nominally safety, we're talking about addressing our best, using our standards, design our streets safely and such. When we start to bring in the substantive safety, we want to add in there the highway safety research and results, and then the other key component is then monitor the success or the impact from our decisions on these particular roadways. If we add all those up together, we will fully address our substantive safety on our streets and highways. Now, another key message within the HSM is basically at no point will we say that the HSM is going to tackle or handle all of the safety concerns or basically provide absolute safety. The reality of it is that there is risk in all highway transportation. So the focus of the HSM and the objective is basically ultimately to reduce those numbers of severity of crashes and making sound decisions when it comes down to making alternative-based analysis on our facilities. So this is just kind of mentioning a little bit about, a combination of that nominal safety and this substantive safety. So some example documents such as our Green Book, our Geometric Design of Highway and Streets, our MUTCD, or our Manual of Uniform Traffic Control Devices, and the Highway Safety Manual. It's addressing safety using all of these components. So as we advance the safety knowledge with the Highway Safety Manual, we're looking at developing tools to go from a more of a descriptive analysis. Basically, a descriptive in this case is basically knowing where our high crash segments or intersections are, and moving from that to more of a predictive method of where we would anticipate our high crash segments and intersections to be. So that's kind of setting the stage on general concepts and such of the HSM. Now I'm going to dig a little bit into the content and structure of the Highway Safety Manual. So the manual is broken up in 3 volumes. In fact, I have 3 volumes sitting right next to me, and it's probably about 3 inches in height. When you put all 3 documents together. So it's a pretty large volume set, and this is just the first edition, so I can only imagine that the document will grow over time, especially when we start talking about adding the freeway segments in. But for this first edition, we've got introduction, we've got some discussion on human factors. Basically, human factors here is basically trying to gain a better understanding of how the roadway is viewed from the driver, and incorporate that into some of our decision processes and such. So the human factors is a new component, really, but it's important factor to bring in. And then fundamentals, of which is basically what I'm covering right now. The Part B, roadway safety management process. Part B is really dealing a lot with that planning component and network screening. We've got specific guidance in there that kind of lends itself to that. We're going to talk a little bit about our safety performance functions. We've got safety performance functions in Part B that are used for our network screening that are different than what we have in our Part C, which is in our second volume, which is more of a project specific. So I'll have some examples that I'll share with you in a few minutes. And then lastly, in Volume 3, includes our Part D, which is just our crash modification factors. And what these are basically for is if you have a specific type of countermeasure, safety countermeasure that you're putting in place, there's been research and scientific approach to developing these crash modification factors to tell you when you're making your design or implementing a countermeasure as part of your roadway, what the impact is going to be on crashes. And some of these crash modifications may possibly increase crashes or decrease. So you've got different scenarios here where CMFs can be applied. I would like to speak a little bit on the Part C again, is that we basically have in Part C, we also have CMFs in our Part C, but each of these crash modification factors in Part C are specific to the facility type. So just wanted to clarify that. Okay. So ultimately, the HSM provides the methods to improve the bottom line or help us in our decision-making process for using our available limited resources. Helps in the decision-making process, helps us on the cost-effective and to be more proactive in safety cost-effective investments, and ultimately is to reduce fatalities and serious injuries. So tying in with key terms and definitions, we spoke to this already as crashes as our measure of safety. But to expand on crashes a little bit, we look at, when we speak to crashes, on these types of crashes, we're speaking to a crash that involves a motorized vehicle, at least one motorized vehicle. So that's just important to clarify up front with our definitions. Now, when we speak to pedestrians, cyclists, and motorcycle, it's a motorcycle would be considered as a motor vehicle, but it would be, a crash with a motorcyclist and another road user, such as a pedestrian or bicyclist. The other thing to bring to mind when it comes to crashes is that ultimately crashes are random events. One of the examples that we've used in our previous training is basically, if you were to stand at an intersection, you would know that intersections, there's a lot of crashes that occur at intersections because of the different turning movements and conflicts and such. But really, it's if you stand at the intersection, you really can't tell at a particular time that a crash is going to occur. So they are very much a random event, and that really makes the challenge in addressing safety. So this figure here is right from the Highway Safety Manual. Basically, if you're, if two cars are just riding down the road and same speed, and they've got enough clearance between the two of them, it's fairly low risk of crash. But that's the first item there. And that, as you scroll down a little bit, but things happen. You may have an object that falls in the road, or perhaps a vehicle stops unknowingly, and so you might have a situation with a potential risk of crash. But if you still have that space, you know, and the driver's not distracted as such, that there's there's minimal potential, but you still have a situation. Now, as the driver approaches, then the other component is if they are distracted or if there's an issue with the vehicle and unable to stop, then you might have a higher risk of that crash than the crash occurs. So basically, there's a lot of different components. As I mentioned earlier, there's a lot of risk in just transportation overall, but just the fact that it gets down to the actual crash occurring makes it very random. There's a lower chance that actually crash occur from the different scenarios that are shown here. Okay, predicting crashes. One of the, when we start talking, oh, go ahead.
Before you move on, there was a question in the chat about CMF. There are two different acronyms that are used for CMF. One is in the HSM Part C, and the other one is in the CMF Clearinghouse. If you can please briefly talk about how not to confuse those.
Yeah, the CMFs that are in the Highway Safety Manual have basically been vetted through the researchers and the FDOT team, and basically have a star rating. So the ones that are in the HSM are very are widely accepted. Now the same CMFs are actually included in our FHWA has what they call a crash modification factor clearinghouse. Now within the clearinghouse there's thousands. In fact, the CMFs in the clearinghouse are growing each day, and there's above and beyond in the CMF clearinghouse what is in the HSM. But the ones that are in the HSM are also included in the CMF clearinghouse. So that's just an important point there. Now, in the CMF clearinghouse, they also have what they would call a crash reduction factor. And the crash reduction factor and the CMF are very similar. In concept, they're the same. The only thing that's different is basically the CRF is basically equal to 1 minus the crash modification factor. So they can kind of be used interchangeably. It's just important as you use the CMFs that you are looking at the star rating, because the star rating within the CMF clearinghouse includes different criteria where it's been kind of vetted through the research community, where your sample size of projects is high, the process that they use to do the analysis is following the HSM guidelines and such. So I hope that helps to clarify that CMF question. Okay, very good. So I'm going to move on to crash frequency. When we speak to crash frequency within the HSM, we're looking at the number of crashes by year. So just to clarify on the crash frequency. So ultimately it's a number where it's a number of crashes per year. So in the past, what we talked about with our crash estimation, we would basically use our historical crash records to determine, our hot spots, whether that be segments on our intersection. But with the crash estimation tool of the HSM, we're able to predict the crash frequency. So basically, on the historical component, we looked at, we can look at how did a facility perform versus how should a facility perform. So as we move forward with the crash estimation tools of the HSM, we can dig deeper into predicting how should a facility perform, rather than just reacting to how did it perform. All right, so with the Part C, now we're talking about predictive method and speaking to the use of the HSM on a more of a project specific, based on those facility types I showed earlier, that we have we've got equations where we can determine the expected average crash frequency with using specific base conditions for our geometric design, and then including a traffic volume in our equation, the length, and a given time period. So I've got some examples that'll speak to that in just a minute. So when we start speaking of expected average crash frequency, what we look at that is basically we're looking at similar facility types, and we would group those together to come up with a expected average crash frequency for a particular facility type. In this case, this would be a signalized intersection. It looks like it's perhaps in an urban area, so it's an urban intersection type. I see I've got one through lane on this side, so it could be a multi-lane divided 4-leg signalized intersection. So we would look at these types of intersections throughout the state and come up with an expected average crash frequency for this type of location. And when we start talking about crash frequency, this expected average crash frequency, it's more or less a short-term measure, because we expect, with over time changes to this location. So, for example, on this particular location, we see that we've got some on the far side. We've got some residential apartment complexes and such. On the other side of the intersection, we basically see a vacant lot. So, time tells us that over time that there's very likely that we could have, some type of development there on that corner parcel. And with that with that change, then the change is a little bit more dynamic to the intersection. So when we speak to expected average crash frequency, we're speaking short term. We're not speaking long term. So I just wanted to clarify on that with this in Part C on the predicted methodology. Okay. Data needs and constraints. So some of the data needs that are required basically is having the facility data, traffic volume data, and for applying what we would call our empirical Bayes method, we would need the crash data. So some of the crash data, just to clarify a little bit on the crash data limitations, is it's important to bring into account when you're looking at the crash data the quality and accuracy as provided by the reporting agency, reporting thresholds, understanding when we start speaking to different severity levels of the crash, that you bring that into account. That ties in with severity. You may find that you may have different jurisdiction differences in regards to an agency reporting a crash that occurred in the left turn lane and such. And then one of the overlying principles to all of the crash data, of which the HSM takes into account is what we would call this regression to the mean. So, we talked early on about this randomness of crashes, and it's hard to predict where the crashes are occurring, and this concept of regression to the mean kind of speaks to that. And part of the, when it comes down to crashes and the randomness of it, basically it just follows what they would call a natural crash frequency, and with also take into account some of the different changes in the roadway type, from perhaps a particular facility where you might have a high roadway driveway density, and you might go through the corridor, and you may find the only thing that changes, everything stays the same, the lane width, the number of lanes, the posted speed and such, but just perhaps the driveway density changes. That does make an impact on the crashes. So just an example of those roadway characteristic variations. So the concept of the regression to the mean. Basically, what this slide is showing is basically over time, it's tracking in red what the roll value is, and on the x-axis here, how many times you rolled that dice, or the die. So the red's the roll value, and the blue is that cumulative average. So you can see at the beginning, from these 0 to 20 rolls, that basically it was, ranged from 1 to 6, just a wide range. And the average here is kind of reflecting that. The average for this first few rolls, ranged from 5 to 3. And then as you did more rolls, you come up to this mean value. But you can see that the regression to the mean occurred after we did, it started tapering off about after 40 rolls. So during this initial, it was just kind of all over the place. So basically the big takeaway here is this regression to the mean concept is over time, this value, levels out. So that's the concept of the regression to the mean. So in the past, what we would have done, and this is right from the Highway Safety Manual, is basically we would use our historical crashes, perhaps maybe three to 5 years. And so if you look at the short-term crashes and make your decisions, that many times you might find that you might make a decision here based on a high crash and really do nothing at a particular site, and then because of the randomness of the crashes, they drop. So the takeaway here is that if you look at short-term crash frequency, how it's very varied, but if you look at that longer time period, that you get a better expectation of your crash frequency. So we spoke a little bit about that short-term, long-term, so one of the things on the roadway environment variation is the changes in land use, traffic volume, geometric design. There's just a multitude of different changes over time that occur on a site. So this is why this helps justify that need or clarification that we're looking at short-term duration. So this is another slide kind of tying in with that regression to the mean and the regression to the mean bias. This is just a observed crash frequency over the years, just kind of showing just a random change here. And so we're looking at a site to do some improvements. We see that there's a spike. So we base our decision on these before average crashes. So we look at this period and get those average there. So we select the site based on that short-term trend, And then in the after condition, this is our average here. So initially, that our perceived would be effectiveness of the treatment would be the before evaluation and after, just comparing those two. But in reality, if you look at the crash data over time, perhaps like for a similar site where we made no changes, that crashes overall dropped over time, without the treatment. So that would kind of get down to that regression to the mean concept. So our actual reduction due to the treatment, we'd be looking at that from that longer year average. So just concept, sharing with you the biasness of not incorporating the regression to the mean. Yeah, so ultimately, if we don't take the biases into account, then we cannot say that the crash difference is due just to the treatment. All right, so moving into the predicted method overview. Our simplified predictive method from the models in the HSM, we've looked at these similar sites and come up with these models. We've looked at adjusting the models for specific site and local conditions. This would be through developing of calibration factors, and I'll speak to that at the very end as a resource that we have for Florida. And then if we have crash data available, that we might be able to use our EB method, and this accounts for that regression to the mean. So the elements of the predicted method, safety performance functions, our crash modification factors, our calibration factor, basically the sites that were developed for the safety performance functions were from other states. So in order to apply it into Florida, we've developed calibration factors. And lastly, on the predicted method, on the empirical bays, if crash history is known, we can apply the EB, empirical bays or EB. So this is kind of a standard predicted equation here, where we would have our safety performance function as a component, and then we would multiply that safety performance function by our various CMFs, and in here, the CMFs are specific to each of the base conditions for the function, safety performance function based on their facility type. And then all of that would then multiplied by our calibration factor. So I spoke a little earlier about our calibration factors for Florida. Have those posted on our safety website here. I'm going to touch base on this again at the end. But these are the calibration factors set up for Florida. Our rural 2-lane undivided, rural 4-lane divided, urban 2-lane undivided, urban 3-lane with a two-way left turn lane, urban 4-lane undivided, urban 4-lane divided, urban 5-lane with a two-way left turn lane. In our intersection calibration factors, rural stop controlled, 2-lane 3-leg stop controlled, rural 2-lane 4-leg stop controlled, rural 2-lane 4-leg signalized, rural multi-lane 4-leg signalized, urban 3-leg signal, and urban 4-leg signal. So those are the only, those are consistent with the facility types that we have presently in the Highway Safety Manual. So tying in with our fundamental element 1 on the safety performance functions on a predicted method, basically, as I mentioned earlier, looking at these different sites, we would bring those together and follow a statistical modeling process to develop these SPFs, and we develop a mathematical expression, and then use that mathematical expression to determine what our estimate average crash frequency would be for the base condition, and speak to that base condition in just a minute. So from that calibration sheet, basically it's the same thing here with the specific facility types: rural 2-lane, rural multi-lane, urban and suburban arterials. So this is an example of our safety performance function. This will be for a rural multi-lane highway 3-leg stop controlled intersection, SPF. These components, the A, the B, and the C, are components that we would take right from our table within the Highway Safety Manual. So you would basically plug those in. And you would also use the AADT. This is an intersection, so you would have the average annual daily traffic for the major and minor intersection. So this is just for training purposes to kind of show you what an example of a safety performance function. And then this table at the bottom is just showing the predicted average crash frequency and its change with the AADT on the major, and then these are just showing the AADT on the minor, and just to kind of give you a feel for crashes. So for example, the predicted crashes for this particular intersection at 40,000 on the major, and like 5,000 on the minor would be right at around 10. So on the base condition, there's another example. A safety performance function has its own base conditions. So here's another facility type, a rural multi-lane undivided segment. Base conditions would be 12 feet, shoulder width and type 6 feet paved, side slopes 1 to 7 or flatter, lighting is none, assume none, and automated speed enforcement none. So if your project is different in these base conditions, then we would have crash modification factors that would adjust our SPF, safety performance function, to accommodate that change. And another example, this is right from the HSM, and so just to speak a little bit to the base conditions here, rural 2-lane 2-way roads, similar lane width 12, shoulder width 6, shoulder type paved. Those are 3, and then we also have what we call a roadside hazard rating of 3, and basically if you have high number of fixed objects on your shoulder, then your roadside hazard rating would be higher. Our driveway density, here we're looking at 5 driveways per mile. Horizontal curve, vertical curve, centerline rumble strips, passing lanes, 2-way left turn lanes, lighting, automated speed enforcement, all would be none, and then grade level. So we would have, if there were differences in these base conditions, we would have a CMF to accommodate each of these components of our that would adjust our safety performance function. Okay, on the crash modification factors. Crash modification factors represent the relative change in crash frequency due to a change in one specific condition when all other conditions and characteristics remain constant. So these CMS were developed based on this understanding, and it's important to bring this to account because many times we see different definitions out there. So this was the best one that we found as a team in incorporating into our training. So in concept here, the ratio of the crash frequency at a site under two different conditions. Condition A is a change from the base, and condition B is the base. So, for example, I got a follow-up example on this showing lane widths, but this is just a background on how the CMFs are determined. So, for example, here we've got a average crashes on 12-foot lanes. 200 is our base condition. Average crashes 11-foot lanes, 210. So just for training purposes, you know, we're using this as an example. Our CMF then would be 1.05 based on the adjustment in the lane widths. The same one with automated speed enforcement. For the CMF with automated speed enforcement is 0.93. So in this regard, since we have a CMF less than 1, it would reduce the crashes. So we would multiply that number 0.93 times our base condition crash frequency. So in concept here, we've got our N predicted, which would be our safety performance function crash numbers, and we multiply that by each of these base conditions where we have a CMF. So that automated speed enforcement, if we had that in place, we would include that in our CMF here, and multiply that through by our other changes from the base condition. Applies CMF, difference in geometrics, roadside conditions, and lighting. Now, the other thing that's important to bring into account on this applying the CMF is when we do our analysis that if there are differences such as these in the base conditions, that we would have to use that to bring into account our homogeneous segments and such. So if we have a change in our base conditions, then when we do our analysis, we have to break that segment up and do follow up with another segment to determine our predicted crashes based on these change in these base conditions. So rural two-way lane, two-way roads. Once again, we've seen these before, but these are the different references that you would go to in the HSM to get the CMFs for each of these. So fundamental element 3, our calibration factor. When we speak to the calibration for Florida, right now, in the calibration factors we're using for local conditions, we're speaking just to the state of Florida. We've looked at more regional calibration factors, but there wasn't a big change in the numbers, so right now we're looking at just doing calibration factors for the whole state. And so basically it's taking into account these local variations, crash reporting thresholds, driver populations, etc. So for the calibration factor, what we're looking for is from those predicted crashes for those particular site types, we're looking at those, and then we capture our observed crashes at those same sites, the same similar sites within our region, Florida, and then that ratio, whatever it is, that's how we would determine our calibration factor. Sounds very simple, but it's a huge challenge to do for a state. So had already showed these, but basically these are just showing what the calibration factors are for these facility types for Florida. And these are the intersection ones. Now, we are right now in the process of updating these intersection calibration factors, so I would anticipate these to be out within the next 6 months or so. So tying in with our fundamental element 4 and predicted method is our EBs, our empirical Bayes method. So we've gone through the first step where we've used the right model based on our facility type. We've adjusted it, model for both using the appropriate CMFs and our calibration factors. And now we're going to use the empirical Bayes method. And one of the key components of the EB is what we call a weighing factor, of which each of our safety performance functions have, that we take into account that kind of basically normalizes the data so to account for this regression to the mean concern that we had earlier. So for example, from the earlier slide, I showed the safety performance functions for that one facility type. So that would be our predicted number from our safety performance function, and this is just showing an example where we might have an actual observed number of crashes that are higher than that safety performance function, but the use of the EB would provide us our expected number in this case. So right now, from this example, it would be somewhere in between our predicted number and our observed number. So this would be the equation used. We have that predict or expected. Our EB method determines what our expected crash numbers would be. It takes into account a weight adjustment, W here, that shows up twice on this particular equation. The first time is just W times our N predicted, and then we add that to 1 minus, or the difference, and multiply by our N observed. And one of the key components on this weight adjustment is this over-dispersion parameter that is specific to each of the safety performance functions. So elements of the EB method, only when predicted and observed crash frequencies are available. We want to apply that weighting factor. If the crashes are over-dispersed or extremely random in this particular facility, we want to use that weighting factor to adjust for that. The EB method produces the expected average crash frequency. And it looks at both, it takes into account both past and future conditions. All right. So that's 1 hour. That's my 1 hour segment overview of the HSM. And what I'd like to do now is spend a little bit of time and speak to some of the resources that are out there for HSM, both on a national and for Florida. So let me bring those up really quickly. So that first link I have there is this Highway Safety Manual. It's basically just highwaysafetymanual.org. And one of the biggest takeaway from this particular, I think, is basically some national guidance. We talked about who our audience is, and FHWA has participated with AASHTO to develop some good documentation to help, and they've also developed some follow-up training. This 1 hour overview is nowhere near enough training to really get into the details and really apply the HSM. So two things I wanted to kind of show with you. This is this implementation guide for managers is a good document that kind of helps with kind of understanding how you would bring it into your agency, local agency and such. The next link, on this particular link, which is of value, is a spreadsheets for Part C. We talked a lot about the safety performance functions and such, and these homogeneous segments concepts. These spreadsheets that have been developed, you can download those here, and just provides a bit more as a tool in your toolbox that you can use to really incorporate HSM. There's some guides in here for developing quality crash modification factors. Tried this link earlier, but that did not work, unfortunately, because they had there are some other spreadsheets that are out there that are more refined, but they're not posted right now.
Joe, when you go back to the PowerPoint, if you can copy and paste the links into the chat window, there are some that would like to kind of follow.
Oh, okay. Yeah, I'll do that. Sure, I'll do that right now. Yep.
That's selectable.
I have to escape out of the presentation here.
Or maybe copy them from from your browser once you get there.
Yeah.
But yes, again, all these slides will be available from that Tampa Bay Traffic Safety website that is in your registration email with the link. So all those will be available to you.
Yeah, let me Okay, Anthony, could you try that first link and see if that works for you?
Yeah, that works.
Okay, I'm going to do the other two right now.
Perfect.
This other one is right from the AASHTO site, but this other one's just focused on the training that is out there. Training, and then this last one is basically just our safety, our FDOT information that we have related to HSM implementation efforts. So let's do that. Okay. All right, sweet. So that's so each of those links now are posted, Anthony. Can you confirm that they all three work?
Yeah, they're working on my end. We're hearing in the chat that they are working as well. So we're good.
All right, sweet. Okay, so I'm going to move into this other one, this other AASHTO site, which is on the training. So here's a free HSM online overview course. Free course here, NHI. I would encourage you, if you're interested, the course consists of 13 self-paced informational modules that can be taken in any order depending on the student's prior knowledge level, interest, and time available. So this is a great resource. It's got 13 modules, which is awesome. It covers both on the Part B, the roadway safety management process, and then along with the predictive methods in Part C, and then also the CMF. So a lot of what I briefly covered today, it goes more in depth on. That's a great resource there. And they actually have, years ago, I think it was like 2010 or 2011, they did some FHWA webinars here, and they've got them posted, like on YouTube, and some of them are still there, but that's just another resource you can use to check out those videos. All right, now the last link I'm going to show you is in regards to for Florida specific, and this one we've covered some of the information today, but want to just kind of showcase really quickly what's here. We've got our crash distribution here. We've got our calibration factors. Latest is 2012. The agency as a whole has been implementing the HSM, so I have an organization chart. An implementation summary. It's dated somewhat, but I am in the process of updating it. I plan to have that posted within the next month. And implementation plan timeline. Also have on here some presentations that have been done internally to our executive at our executive workshop, and to our districts to promote district pilot projects. And some of the same links here. You know, the highwaysafetymanual.org is another really good site. Highway Safety Manual Data Needs Guide. TRB, I mentioned that the HSM is very data intensive, so there's some guidance there. And then we spoke a little bit about the CMF Clearinghouse. There's a link there. So just to kind of show you real quick on as an agency with our implementation efforts. As an agency, we are moving forward with implementation of the HSM. It's been blessed by Secretary Nath Prasad. As I mentioned about the overlap amongst the application of the HSM, we have our Assistant Secretary for Engineering and Operations involved as a central office champion, Brian Blanchard, our Chief Engineer, Tom Byron. We got our planning folks, our Transportation Development Administrator, Mr. Bob Romig, and then my boss, Chief Safety Officer, Laura Hollingsworth. And then down to a district level, we've got a lot of our district safety engineers, each of the districts, along with roadway, planning, traffic ops. Each district's a little different. And then here in central office, we've got implementation team, including myself, and then roadway design and planning and traffic operations. So just, you know, it's a lot of people engaged in implementation efforts of the HSM. How am I doing on time, Anthony?
It's 11:26.
Okay. All right, just a few more minutes.
Yeah, so we
I do
scheduled 30
okay.
minutes left. Yeah.
Yeah, well, I didn't anticipate using all the time, but so what I like to do is really kind of cover lastly this timeline. This was done initially back in June of 11, and so I could tell you right now it's old information, but some of this historical information is valuable. The fact that we've done quite a bit of efforts back to 2009 and being engaged with some lead state initiative efforts and training and RCI and such, roadway characteristics inventory, coordination for the data. So just another reference there for you. Okay, go back to the presentation. In the presentation, I just did a few screenshots here. That's what all that those are as a backup. All right, so just to kind of retrack here, learning objectives, cover the purpose of the HSM, who our audience is, the structure, the 3-volume set in the 4 parts, advantages of the HSM, and really just covers a few resources that are out there, at least that I'm aware of, that might be of value to you. So with that, Anthony, any questions in the pod or in the chat box?
There are no questions at the moment. We'll give all the attendees a few minutes to think of any if they have some.
All right. Okay. And maybe my only questions will be from Dennis.
Rudy always comes in and asks.
Or Rudy. Yeah, Dennis or Rudy. Those guys, I'll tell you, man, they're...
While we wait for questions in the chat, I wanted to remind everyone, next week's, because there were some questions and a good bit of discussion today about the CMF versus CRF. Next week's webinar is about the application science of crash reduction factors. So we're going to go into that in more detail and run through some examples and, you know, the actual application of them. We did a good bit of theory and background today, which is important to know, and next week we'll actually be applying the knowledge that we learned today.
Perfect.
So if anybody has more questions about those, covered November 13th.
And that's pretty much by design, right?
Yeah, that's...
It was planned to be that way, right?
Yes.
Yeah, there actually was...
Awesome.
Order and
awesome. I thought it was maybe just a coincidence or something, but I guess it wasn't, huh?
No.
Random. Be mindful as well of the dates of the upcoming webinars. We do have a couple of holidays coming up, you know, Thanksgiving and Christmas and New Year's. These are mostly weekly webinars, but there will be some weeks that we take off in between to accommodate for holidays, so be mindful of those dates.
So any questions?
It doesn't look like we have any questions. I guess we can go ahead and conclude the webinar. That's they either completely understood everything, Joe, or they're completely lost. So
no, it's all good.
It's a great presentation, and all questions were answered.
Well, really, everybody should have my contact info. So if something, you know, comes up later, like, you know, you're sleeping, you know, over tonight, you know, sleeping, and you think about a question, just feel free to give me a call or an email tomorrow.
Okay, so I guess this concludes our webinar.
Right.
I'm going to go ahead and end the recording.